Don't miss out on this one. Let's talk about some important concepts in sets. Complement. The complement of a set means things that are not in that set. So the symbol for the complement is this. So here we read this as A complement, or if it is on B, we say B complement, meaning things that are not in set B. To understand this, let us consider this example. So we are given the universal set, which has elements 1, 2, 3, 4, 5. Then we are given set A with elements 1, 2, 3, and set B has elements 2, 3. So this universal set is the mother set, and it is a set which has these smaller sets. So set A is in the universal set, and also set B is in the universal set. So A belongs to set E, and also B belongs to set E, like that. Now, let us talk about the complement of the set. So if this is our set A, what will be the complement of this set? To find the complement of this set, we begin with a notation. We say A complement, meaning things that are not in set A. To find A complement, we should be looking at set A. So we see that in set A we have 1, 2, 3. So A complement means things that are not in this set. So what are those things that are not in this set? So we go back to the universal set, we check for those things that are in this set, but they are not here. So we see that 4 and 5 are not in set A. So when we say A complement, it means things that are not in set A, and the only things that are not in set A are 4 and 5. So we write 4 and 5. That's it. Now let's go to the next one, where we want B complement. B complement means things that are not in set B. So for things that are not in set B, we have 1 is not in set B, like that. Then we have 4 is not in set B, and 5. And definitely 5 is not in set B, like that. So this is how we use the complement. Now, since we know what the complement of a set means, let us talk about another law in sets, which is very important. This is known as De Morgan's law of sets. So De Morgan says, when you're given A complement intersection B complement, like that, it is just the same as the complement of A union B, like that. So this will give the same results as this. That's according to De Morgan's. Then De Morgan's again says that A complement union B complement is just the same as the complement of A intersection B. So A complement union B complement is just the same as the complement of A intersection B. So these relations are true. And we can just use a simple example to verify this. Now, before we continue verifying this, we have to note that this intersection here, this symbol, is known as intersection. And intersection means things that are common in the sets which you've been given. Then the other symbol, union. Union means putting what is in this set and the other set together. That is what union means. Now, having these ideas in our mind, let us continue. So I'm going to use the same example to prove that De Morgan's law holds. So I'm going to list down the universal set. So our universal set has elements 1 to 5. So we are always supposed to refer to the universal set. So our universal set has 1, 2, 3, 4, and 5, like that. Then let us list our set A, the same sets we are using. So set A has elements 1, 2, 3, like that. So we say set A is equal to 1, 2, 3, like that. Then we have set B, we just have elements 2, 3. So for set B is equal to 2, 3, like that. Let's show now. Here, the instruction says we should find A complement first. So A complement means things that are not in set A. So I will write it down here so that we can follow. So we are saying A complement, we have A complement intersection B complement, like that, is equal to, so let us find the answer for this one. A complement means things that are not in set A. So if we look at our set A, we have 1, 2, 3. Now let us list things that are not in set A. So things that are not in set A are 4 and 5. So I'll write for this one, we have 4, 5, like that. Then we have the intersection on the middle. So I'll put intersection like that. Then I close. We are looking for B complement. B complement means things that are not in B. So things that are not in here, in B. So things that are not in B, we have 1, 4, and 5. So those are the things that are not in B, like that. Let's finish this now. So when we have this intersection means the things that are common in the given sets. So if we look at these two sets, what is common is we have 4 is in here, then also 5 is in here. So 4 and 5 are common. So we write like this. Yeah, so this is A complement intersection B complement 4, 5. We are done with that one. So we are just solving the first side, A complement intersection B complement. The other side says the complement of A union B. Let us find the answer for this one. So I'm writing A union B, like that, close, then complement. Let us try to find this one. So we're going to follow the instruction as included in here. So you can see that the complement is not on this letter and also it is not on this. So this means that I'm going to start with my parenthesis like this. Then the instruction says I should list set A, the actual set A. So if you check here, the actual set A is this one, which has elements 1, 2, 3. So here I'm going to put my set A, 1, 2, 3. Then we do that. Now, then we have the union on the middle. So I'll put union like that. Then we should list set B. So our actual set B is this one. So it has elements 2, 3. So I'll write 2, 3 like that. Then after that, after listing set B, this one, we should close parenthesis and put the complement outside like this. Then we can simplify this now. So inside we have this set union this set. So it means that we should get these two sets, we put them together. So we have 1, 2, like that. Then we have 3. Then here we have 2 and 3, but we've already listed them. Since they're already found in this set, we don't have to repeat elements. When we combine this set and this set together, we get this set. So we close. Then we have this. Now, when we combine these two sets, remember we still have this complement. So we put the complement here, then we proceed. So we say this complement of this set, meaning things that are not in this set. So which things are not in this set? We go back to the universal set here. So in this set, we have 1, 2, 3. Now, what is not found in this set? We have 4, 5. So we say the only things that are not in here, 4, 5, like that. Okay, so this is our answer. Now, if you check this one, the first one we started with A complement intersection B complement, the answer was 4, 5. Then here, the complement of A union B, the answer is 4, comma 5. So the answers are the same. So this shows that De Morgan's is true. When we say that the A complement intersection B complement is just the same as the complement of A union B. Now we have the second one. A complement union B complement is just the same as the complement of A intersection B. This one is yours. Try to prove this one. You see whether you're going to get the same answers using the same examples. Make sure you drop your answers in the comment section. And if you like my videos, please support by subscribing, sharing, and also making any contribution to see these videos running. Thank you very much for watching. See you in another lesson.